What's going on here is the like microservices approach, separate components, each with their own auto scaling infrastructure. What Modal is trying to do, one of the high level goals, is to make building flexibly auto scaling microservices architecture in Python actually good instead of hugely painful. What we're going to do is we're going to do a deep dive on a production application that I've been running for a little bit over a year, maybe a year and a half on Modal, dating to before the time that I was actually even working at Modal, when I was just an enthusiastic early user. And that application is the QArt Codes generator. So let me pull that. So on the right, we have a prompt. We can generate a QR code that will link to or contain a representation of the text in the bottom there. Let's run that again so we can see it. Takes a couple of seconds. This is running on an H100 GPU, so it takes about 5 seconds. This is running, I think, Stable Diffusion 1.5 because that one had the best QR code control net. Okay, so here's like a standard QR code. So we generate that, and then here's the fancy QR code. So let me just live do an attempt at scanning this QR code. All right, that QR code is scanning for me. If folks want to pull out their phones and attempt to scan, we'd love to know. What I've found as part of this project is actually different QR scanning setups, different phones, different versions of phones, different packages that implement QR code scanning will actually give different results. And so there's not really one such thing as a scannable QR code in the same way there's not one such thing as, SQL. There are many SQL dialects. There are many implementations of the SQL standard, but there is not one SQL. Yeah, great. Yeah, so it looks like it worked for Jasper. It depending on the implementation of your QR code, not just scanner, but then also how it's handled, it will either add an implicit HTTPS and bring you to the Modal website, or it will search it in your search. Yeah, so Juan's using maybe a different machine or a different operating system, which chooses to open the Modal homepage. So yeah, just to show a few more of the like features on the front end. We aren't going to spend too much time on the front end unless people have questions about it. So the way this, we just got like a simple little button here, download the QR code, like this version of it, or you can kind of move this slider to a specific spot and then click this button, download it. There you go. So that one's there to sort of like make it easier for the QR codes to scan, and also kind of has like a fun aesthetic, like mixing old school and new school. And that's what I'll frequently use when I want to make a QR code that's like production grade, where I definitely 100% want to make sure people can scan it, and like any, compliant QR code scanner can handle it. So that's the application on the right there. And then on the left, we have the code for it. So I'm going to jump over to my VS Code terminal here. The code for this open source front end and back end, you can check it out. It's built on top of open models. And so yeah, you can deploy this yourself if you'd like. You can play around with it. Yeah. So Meant as kind of like a demonstration application on Modal. But because this is like more complex than a lot of the stuff that we have in our examples, because it's intended as like, a real application, like I generate QR codes with this and I use it for webinars. I use it in my slides. I use it to give GPU credits to people. This is a little bit more robust, a little bit more production grade than a lot of the stuff that we have in our examples repo, which is really meant as documentation. It's meant to be like easily extensible and easily maintainable, and not like, not always fully production grade, like the way that the testing works, for example. So I wanted to talk through some of the things in this repository that maybe more closely resemble a full production application running on Modal than our examples do. So yeah, let's dive in. Maybe the first thing is if we go up and if we look at the top level of this repository, you'll see that there's a bunch of stuff here for, we've got package.json. We've got a Tailwind config. This is all front end stuff. So the front end here is a regular JavaScript front end. I want to say it is React, but not Next, probably Vite. Yeah, there's a Vite config running on Vercel. So this front end here is like has nothing to do with Modal except that it interacts via an API. So if I do, I can maybe find that that interaction here in the source. Yeah, so like there's an interaction um, with Modal. Oh, it wouldn't be modal.com, modal.run. Yeah, so if we look here in there's like a backend URL that happens to be running on Modal as an implementation detail from the perspective of the front end, but rather than being a tightly integrated front end and back end. So in a lot of the Modal examples, a lot of the examples on our documentation site, you'll see that we host the front end on Modal. We'll like host a little FastAPI static server, or we'll even like run a node backend and serve it on Modal. And like while that totally works, and while we intend to improve and increase our support for languages other than Python, right now it's pretty hard to argue that a production application should be using Modal as a server for its front end components. So a more common pattern that you will see is this divide that's based off of URLs. So like you're standing up a service and a REST API on Modal. So let's see where that comes from in the backend, which is in this backend directory. All right, so if we look in this backend directory, we see we've got a make file and a readme. So fun little bit there, the make command will pull up this in ASCII, or not ASCII, but this terminal QR code and list the commands for the make file. So looking there, it looks like we've got this help command that is showing us all of our commands. And the main one that I want to focus on is API at the top, deploy the generator and API on Modal. So this make file is here to like formalize the deployment process. I think the one thing missing from this for a production application is this isn't integrated into like GitHub to give you continuous integration and continuous deployment. It's manually triggered. So if I want to like update the production environment, I just set the environment to prod and make the API. And it'll run. Now, there's some nice things for, continuous integration and deployment. Like you'll see that it, installed a bunch of the packages, and then, it includes verifying with Modal. So it's like it's all in one package that, apart from secrets, should run in just about any environment. So could easily be ported into CI, but that's not built into this repository yet. We'd need like a little actions workflow. But that's what this does. You can see there's two separate steps. There's a deployment of the generator, which is the deployment of the back end of the back end, the ML inference service that generates these QR codes. And then there's a separate deployment of an API in front of that. And that is the component that the front end is going to communicate with. So you can see here, the API, we have a hosted function on Modal for that API. It has a URL. That URL is the same one that is used in the front end for communicating with it. And so there's a couple of reasons for that kind of split there. One reason is just sort of like general separation of concerns. There's like setting up the core service that runs on GPUs and worries about ML models and how to install PyTorch and CUDA toolkit components. And you really kind of want to separate that out from the like web Python world. Both of them are have pretty strong opinions about packages. They have like frequent conflicts. If you've been traumatized by the Pydantic 2 upgrade and the NumPy 2 upgrade, then you may know what I am talking about, and it's beneficial to be able to separate those out. And it's not just a separation of concerns that's like just, oh, this is in a different Python file or something, or this is a different module. But with Modal, it's like actually two distinct Python environments that we deploy. So let's like start diving into that. And I think the best way to do it, and the one that's sort of like most generic, is rather than relying on like my knowledge of this system or of this application, or of like, let's look at if you look at the files, it's like, oh, what is API? What is generator? Like, I don't necessarily know what any of these things are. And it looks like the API slash API. Rather than looking through this, let's take a look at the actual content of the make file and use that. So it looks like, um, yeah, we've got, this is our API target that we were running with make API, modal off here. All right, that down here is just like setting up the authentication, making sure that runs on each command. Now we've got the modal deploy command. So we have modal deploy generator, and then when we're going to prod, we deploy the API as well. Otherwise, we just serve the API. So modal serve is a way to like stand up something that's like a web function or a web application in an ephemeral way. And that's kind of the default behavior if you just do make API without without any of that env equals prod at the beginning. And I can show you what that looks like, actually. That's kind of fun. Give it a sec. Let's see. Oh, right. No, that doesn't have a docs route. It is at the root there. Okay. Let's get that in dark mode. Can we get it in dark mode? Oh, we're in private browsing. I don't have my dark mode extension. Apologies for your retinas. Yeah, so this here is a Swagger or OpenAPI documentation UI that we have built in here that's useful for kind of like playing around with and testing things. So this is going to hit this served version of the API. So you can see here, you should see this get health. That's me hitting it from this API here, and it's spinning up right now. Oh, no, it's not spinning up. It already finished. Right. Short get request. All right. And we can try some different, like you can see there's like documentation here. We've got like schemas for stuff. So this is like, kind of the sort of things you'll have in like an actual grown up application, like documentation and typing for your API. So if we look maybe at this, looks like there's two fields in this health response and this flag. So I can like pass this serious equals false or serious equals true. Let's see what happens there. Oh yeah, this is a little joke. Instead of 200, more like 100. Am I right? So the original version of this application was written at a hackathon, so it had a bunch of sort of fun little bits in it. So anyway, so all of this here is like the development server version. So I can run this, play around with this, change the code without impacting the production application, in part because it has this different URL here. You can see it has this -dev. So like setting up a nice way to be able to use that like development server and interact with the development server separate from interacting with your production deployment is a like pretty important part of getting like a good development workflow for production application in Modal. All right, let me turn that one off. All right. Okay, so that's all right. Those are our commands: modal deploy, modal serve. It's deploying API. So that's this API folder. So fun fact with Modal, it's sort of like oriented not just to individual Python files, but also to Python modules. So you can like run or deploy a Python module. So we went into the API folder, and now let's look at it. We've got an init file here. All right, so this is what like Modal is going to hook into for that deploy and serve. It's going to look in here for an application to deploy. So that's this app here. So let's go to definition to find out where that is coming from. Maybe we can find it here in this common directory. So that's where it's originally defined. But actually zooming back out, I don't really want to go to definition where it was originally defined. I want to find this module that it's coming from. So then sort of walking you through this just because this is kind of like showing off a little bit of like how Modal interacts with like a file system or a module structure, which again, because of those sort of more single file orientation of our like core documentation and examples, is not something you're going to see a ton of in our documentation. So let's go to definition. Can we go to definition for main? Yes, great. Love it when the IDE actually works. So now that's where the app was coming from, and the version of the app that's getting deployed and served. So now we're here in main.py. We can see that we're bringing in a couple of things like that app from the common file, that common.py file. Had a bunch of like definitions of kind of like constants, shared things like a baseline environment, Python version, all of that stuff is in that like common module. And then we're like wrapping that to put our API around it. Right. Okay. So, and the real, like the work here is being done again, like deferred a little bit over into this create API function. So the like create API function here in API.py is like returning our FastAPI function. Sorry, our FastAPI app. So this here is like from the FastAPI library. And basically when you want to integrate an ASCII app with Modal, including a FastAPI app, you make a function like this that like returns some like it returns an ASCII app, and we will take that and then like wrap it and host it. So in the same way that you can like add middleware to an ASCII app, we're kind of like using your app as middleware when we like host and to like host it on Modal, give it all the like fancy features, handle URLs, etc. Um, so that's what's going on, jumping like back up into our main.py file. That's what's going on here. I'm saying, hey, here's a function that I want to run on Modal. It is going to return an ASCII app, and I want you to turn that into a web app for me. And then this here is the implementation. So this is a pretty common way that we end up integrating like with other people's libraries, with like frameworks, is we sort of like wrap around some function that returns or creates an app of in that like ASCII framework. Also WSGI, if you're familiar with this like web Python stuff, ASCII is the asynchronous version. WSGI is the slightly older synchronous Python version that like Flask is based off of. So you can also do WSGI apps if you'd like, or anything that can listen on a port with web server. But ASCII app is nice for being, kind of more performant at large request per second levels if you can take advantage of asynchrony in handling results. So if you're reading and writing from files, talking to databases, all of that stuff, ASCII is really nice. One point about that, with ASCII, in order to really take advantage of it on Modal, you'll want to turn on this allow concurrent inputs flag. Allow concurrent inputs means that when an input comes in, like a web request to be routed to your application, it doesn't get its own container. The default behavior on Modal is we spin up a container for each input. And then like, with that would cause like a pretty large number of containers to spin up if you were like, you just doing like every web request gets its own container. So that's usually not what you want with an asynchronous server, because you can handle them concurrently. And this allow concurrent inputs flag, which can range from 0, or rather 1, I guess, to 1,000. That like sets how many of them we want to put per container. So then you still get auto scaling here. So if like 2,000 users came in at the same time, then I would still get I would still get the scaling up, that the modal serverless scaling that is like, yeah, that helps you sleep well at night and know that you can handle a traffic burst. Yeah, so that maybe the one other thing to comment on for this one is for modal CPU functions. I really like to use the keep warm flag. I really like to set it so that there's always at least one replica around. And that's not something we do in our examples, again, because when you turn this keep warm on, there's going to be a copy of this function like deployed on modal, and it's running all the time. So normally this is 0, and so there's no live deployment of this on modal. It's there ready to go to spin up, but it's like scale to 0 serverless. And so the nice thing about that is that you won't be charged like anything for hosting that app on modal. The disadvantage is that there will be a short latency when you spin up, because it like takes a couple seconds usually to like spin up a FastAPI app, run a bunch of Python code, do a bunch of imports. You can get that down. Like there's tricks that you can get that down probably under a second or maybe about a second. But there's still that extra second of latency. And frequently with like web APIs, like there's an expectation of at least responding to a request, if not like fully completing the entire purpose of a session, but at least responding to a request in under a second. And so for that, you really want keep warm equals 1. So the current setup with Modal is that you'll get charged for at least 1/8 of a CPU an hour. So this will still actually fit in the free tier. Like at our current CPU prices, over the course of a month, you'll spend less than $30. I want to say it's about $10 a month to like have a warm CPU app. So for a production application, it's a no-brainer to do that. If you're getting any like reasonable amount of traffic, $10 is not such a big deal. And it's going to definitely be swallowed by your GPU costs if you're running, GPU inference as part of this application. But in our examples, in our documentation, we tend not to use this flag because we don't want you to like try out something in our documentation and they get a surprise bill for $10 or $100 at the end of the month. Yeah, I think we also will warn you if you turn this on and then it doesn't get any traffic, because again, we don't want to surprise anybody. But yeah, again, like we're better safe than sorry. Cool. So that's like, yeah, so that's our application. And like, what is this API even doing? Maybe we're talking about here. So what this API is doing is it is basically a like job queue around the raw like diffusion inference. Like Modal helps you set up like a function that like inputs go in, outputs come out. And there's like a bunch of like, you can spawn jobs on that function and then like pull them that like there's the like raw material for that you like deploy when you create a modal function and you modal deploy it. You will frequently, especially when you're doing like, I guess in this case, like a web API, you want like the ability for like an arbitrary front end, not necessarily in Python, not with the Modal SDK, to be able to like query like, hey, what's the status of this job? Oh, I want to cancel this job. You need like a REST API around like job handling and job cancellation. So that's the like primary purpose of this like FastAPI component of the application. Um, so another thing to call out is it does have like there's a data model for this application. So that's also in a like Python module. So all of these modules will be like pulled up with the Modal application when it's deployed. I think there's also ways to like specify which components you want to mount. So this is available locally and remotely. And so you can get like a lot of type hinting and things locally if you have all of the relevant packages installed. And then it will also be present on the remote worker when the thing is running. So you've got a little data model for job status and job requests. So nothing too complicated. There's no database involved, so our lives get a lot simpler. Actually, how that job queue gets handled is kind of interesting. I think maybe, yeah, all the details of it is like pulled over into a separate module, this jobs.py component. So like from the perspective of like this file, this is all being done this is all abstracted away. But what is the content of that abstraction? Let's jump into now jobs.py. So the way that jobs are handled is using a component of Modal called the modal dict. So modal dicts are sort of like an unholy spawn of Redis and Python dictionaries. It's a remote Python dictionary. So you can kind of stuff anything that can be cloud pickled, which is like a pretty large fraction of Python, can go into a modal dict and be accessed pretty quickly from like any modal worker. And the Actually, I think you can, even if you just have the modal SDK, I don't think you even have to be running on our infrastructure to talk to a modal dict. But don't quote me on that. Check the docs before trying it. But the point is that it's a distributed or remote dictionary. So that allows you to like push a job from one worker. Like let's say there's like many replicas of this thing up. I can push to this dictionary and like pull the status from another worker without having to worry about like making sure they're on the same machine or something. So this like kind of distributed dictionary. There's also distributed queues, which you would maybe use for this. Is another way to build like a job queue. Those queues are also built kind of like on a Redis queue style, and so you can kind of queue up under a tag. You could queue up a bunch of jobs. So if I wanted to like run lots of inference jobs, I might use a queue to get like a combo dictionary and first in, first out behavior. So the interaction with that here is all also async. This is actually something I changed just last night if you check the Git history. So you can do either blocking or not, or non-blocking versions of sending information to these dicts. So we just like we this job queue holds the job statuses, and in particular, it also holds the handle that's used to get results. So the modal function runs, and we have a handle that we can use to get its results. And the way we generate that handle is right here. So this is like spawning a remote call here. So that spawn in modal terminology means like run this function, but I'm not going to wait directly here in this process for the result to show up. I want you to give me like a handle that I can use to get the result later. So there's another form of asynchrony or concurrency. It's like I want to run concurrently on another machine, concurrently on Modal's infrastructure, run this. So we're sending in the prompt, the QR code image, and a job ID. And that's being sent to this generate and save function. So the generate and save function, so this is a modal function, and it's deployed on a little separate bit of infrastructure from the front end, the FastAPI component. And this part here is one reason to separate it out is that it has access to like resources that the front end API doesn't. In particular, this here is a little modal distributed file system that I use to save the outputs of the model. So I save the outputs of the model on this remote file system so that later I can go and like pull down the generated QR codes and check like, do they scan? What is the aesthetic quality? So this is used to support like continuous evaluation of the QR code system. So right now, I've only done some very preliminary stuff. You can see there's some GitHub branches that look at sort of evaluation of this model. So very primitive so far, but I've got the infrastructure in place to be able to collect production data and be able to like use it to improve the system, which is pretty important. So the what this does, aside from like saving the QR code to a file, it will also like run the actual generation of a QR code image on like using our generator. So that's this here. So it's another spawn. So we're also like calling out to like a separate container. So kind of what's going on here is like a bit of a like microservices approach here. There's a bunch of like separate components, each with their own auto scaling infrastructure, and a little bit of like what Modal is trying to do. Like one of the like high level goals of this platform is to make building a like flexibly auto scaling microservices architecture in Python, actually good instead of hugely painful. Um, and so that's sort of what led to this like architecture with all these, separate components and spawns and remote execution. And leads to sort of like separation of like kind of clean separation of concerns and like very good like auto scaling behavior and very good utilization of resources. Um, without without me having to get a PhD in Kubernetes or anything. Okay, so this is our second call. Once we've set it, we've got like the job status is set, and then once we get the results back, so this is the part where we're like waiting for the result to come from the QR code generator. Once we get the result back, we throw that up to the job queue. So this is also important, like nice feature. Like I want to save the information of like what QR code was generated because I want to be able to like because I want to be able to like track usage over time and like see whether if I make a change to the model, does that actually help users generate more aesthetically pleasing and scannable QR codes? I want to be able to do that, but I don't want to have to like save it to disk and then send it to them. So being able to do this like have this like job queue that just represents like is the job done and where do I find the result from this like write stuff to a file. Like that's an important thing for reducing or like controlling latency. Maybe an important kind of like engineering point here is that the generation of QR codes with a diffusion model takes a couple of seconds. So that's like kind of the wiggle room that we have in terms of latency, like adding tens of milliseconds, maybe even hundreds of milliseconds of additional latency is okay, because it'll get swallowed up by the seconds of latency that the like core job takes. It won't be as noticeable to users. But adding additional seconds of latency, which is kind of like the worst case scenario when saving files, that would be pretty bad. And so we want to like keep that out of the hot path. Cool. All right. So we've now started to peel back enough layers that we can get to the actual the actual diffusion inference part. You may have come hoping to see some machine learning, and I've tricked you and gotten you to listen about asynchronous web Python instead. So apologies if you feel bamboozled. But yeah, so here's the part where we like the thing that we interact with to spawn an execution on the diffusion model is here. And you'll see that this is modal class lookup QArt inference model. So this is another kind of like dividing line in our API. And this is why we had two steps in the deployment process. If we go all the way back to the make file, you can see that there's modal deploy generator and then modal deploy API. We've spent this whole time talking about API and not generator. So this modal class lookup is a way to say like this Python file, this application doesn't concern itself at all with the internals of the implementation of this modal function or modal class. It only concerns itself with like the interface to that. It knows the function names, it maybe knows some like input output parameters, but it doesn't care about the internal details. It just looks it up. It should exist. It should be like deployed on modal in some app on modal, in some environment, in some workspace. It's deployed, and we're just gonna like look it up and send work to it. So this is like for the like highest level divide is like there's a front end client that talks to an API, and there can be any number of clients that talk to that API. That API then talks to this like job queue, and that sort of creates a separation between like the like high level REST operations and the like management of the state of a running inference and evaluations and observation. And then that is separated from our actual ML operation by this, like, again, another firewall of like, there's an interface. But instead of this one being like a REST API style interface, this is a remote procedure calling interface. So it looks like you're like calling a function in the language, right? It looks like a Python function call and is like a Python function call of some kind down here, but it executes on a remote machine. So that idea of remote procedure calling goes way back. And I think now with the increasing compute requirements of ML and data intensive workloads and the existence of like pretty good cloud infrastructure, it now makes sense to bring back remote procedure calling that was like last popular back in kind of like the mainframe days. So that's kind of one of the like high level visions that I have of like what we're doing here at Modal. Okay, so to figure out the code for that, there's a couple ways to do it. The like principled way to do it would be to then go to the Modal app dashboard, find that uh, find that deployment, and then there's metadata attached. You could find the code. You could find containers that are running this application. There's a bunch of things in the Modal dashboard. Let's just maybe show that real quick. I will have to log in with my GitHub here because I'm in, yeah, there we go. Yeah, so now this is where we're at, not that environment, but this one. So this is the app dashboard for this application. And you can see here, this is QArt inference. So this is the one I was looking for. So when I said there's a principled way to do it, principled way to do it is go into your Modal, like Modal app dashboard, or use the Modal command line interface to like find this this QArt inference. Let's scroll up. This here, along with any other things in this class lookup that would tell you like what environment, like anything like that, to find this guy. And then from here, we can find additional metadata, like who deployed this, when did they deploy it, like what files are present on this thing's file system. Here I see generator.py. If I open this, okay, text condition model called generator.py. All right. Oh, yeah, there's a generator.py file here in the repo. I think, yeah, that's kind of the way that I'll frequently do it when I'm interacting with a modal code base that's new to me, like when I'm helping a user with an issue or like, working with a team member. That's sort of the like exploration that I'll do with a complex deployment to figure out where the actual code lives. Okay, so that was the actual code up there on Modal, and sometimes like that's the like source of truth. That's the code that's actually running. So if you're like debugging not just like the um not just like the code, but also like the deployment process and your mental model of the deployment process. Like this is your source of truth. And you can actually like, you can find like a container like this one. And, if you want to like poke around, you can do modal container exec with that ID, drop in, here we are, there's generator.py. Take a look at it. Like you've got a shell. You've got all the Python dependencies. Let's do a pip list. And I should see like PyTorch is installed in this guy. And I think this will have a GPU. Yeah, this has a GPU, so I can check how's that H100 doing. So all of that can be done right there, which is nice. But yeah, so that's like another thing that you'll have to do in a production deployment that we don't show that much in our documentation is that kind of like interactive debugging or this like examination of the like actual running deployment so you can figure out why it's down. Okay, so boom, code generator.py. Okay, so now here is our text condition generative model of QR code images. So again, it's its own distinct Python environment here. So, we've got like there's some system requirements for image generation and image handling. There's these like sort of ML dependencies. All of that is in here in this generator file. So actually what I'll show you is I'm going to jump down here. So one thing that I like to do, so in a regular Python file, you might put an if name equals main block at the bottom and then like run tests so that you can like run something like a script with like, I want to run like while I'm making changes to this file, maybe I write some quick tests that run like if name equals main, especially if you're like writing a script. So the equivalent of that workflow in Modal is adding a little local entry point to something that you're otherwise going to debug. So let me show you what that looks like. So modal run generator.py is now going to run the code in this local entry point, which includes like hitting the deployed model, um, like a deployed copy of the model here, to like test its behavior. So let's do modal run generator.py. And so now this is going to run this little quick test, which like generates using a like known QR code, and like optionally if you pass it a prompt, it'll run, generate, and I'll use this when I'm like quickly iterating and developing on something, and I just want to like do an end-to-end kind of like smoke test. All right, so not quite wide enough to get this. So that printed the output here. So let's see what does it look like to do this debugging. For for ML stuff, you frequently have stuff that is more meaningful to humans than it is computers as your output, like a picture. And so it's like hard to write a test for like, does this look good? We've got some automations that we're working on for evals, but like frequently you just gotta like look at the data with your eyeballs. And so being able to like generate those outputs like and without having to go through the whole job queue, without having to go through a front end client, it's a major accelerator for your development. And so that's like an additional benefit of that architecture, of that like split up architecture. And like Modal tries to make sure that when you build those kinds of split architectures, you don't like all of a sudden lose your developer experience and lose your development velocity. Just because like, you like we're trying to, architect things properly. So we give you like the ability to add just like a quick entry point to this code so that you can run it. And like, not, yeah, run it on cloud infrastructure with the same fast development speed. Same thing with that like modal serve that I showed at the beginning, like fast reloading, hot reloading. Development server is a thing people associate with local development, not cloud native development. Cool. All right. So we talked through how that one works. Oh yeah, one thing I do want to call out is if you look here, I think, yeah, it looks like we ran on the existing copy of modal dot. Let's see. Let me check the logs to make sure. Data image. Okay, no, this is not the same one that we just ran. Okay, cool. So, um, so what I was just doing there, sorry to explain what I was just doing there. I was looking at this log, which is my like local copy of the logs that shows me what I just ran, and then comparing it to this run that also happened around the same time in production. And around the same time I was running my like local entry point, there was also like a run in production, and I wanted to check, wait, were those the same thing? Because that's not the case. That's not what Modal does. And I was surprised to see a function call show up at the same time. But yeah, we have the logs with timestamps, so you can do that kind of like that kind of sleuthing. So what the point that I wanted to make and that I needed to verify by quickly checking those logs is that this is not running on the production infrastructure. When we do modal run, it's going to spin up a new copy to execute stuff on. And that will still show up. You'll still get like logs and things for it. It shows up in this ephemeral apps section, so that this should be it here. Yeah, 3 minutes ago, generate. There's IVBOR. I like logged a couple of the bytes, the like base64 encoded image bytes. I use that as like some slightly janky request logging in the code to allow this kind of like correlation more easily. So yeah, so this is the execution that I ran. It's for this ephemeral application. So ephemeral applications are a little bit more like running a script on Modal's infrastructure as opposed to like deploying a service. And so that like script service divide is something that I personally, as somebody who like came from more of a researchy background, had to like learn to use Modal effectively. It's like, okay, what do I want to do as like just some like cutty little one-off Python stuff like this quick test, and what do I want to do as a like as like a service, as something that's like deployed, it's reusable. So speaking of reusable services, let's take a look at the actual ML part of this. So this is our modal class. So a modal class is used for something where there's initialization work that's separate from the work that needs to be done to handle every like request or execution. So that the work that needs to be done during setup is put into a class method decorated with modal.enter. And the work that needs to be done on each execution goes into a method decorated with modal.method. You can have multiple modal.enters. There's also a modal.exit and a modal.build. So there's more going on here. Check out the docs with the guide to classes if you want to see that. So the key thing here is that during the enter phase of like spinning up a container is when we like load the model. So this like self.setup here is like creating the model, and then it creates this like little bit of like shared scope, a shared state, the like actual model pipeline. So if you have something that you want like across executions from like run to run, you want that state to be shared. The only place to put it in an app class in a modal class is like as an attribute that you create during modal.enter. If you change the state elsewhere, like those mutations aren't going to be preserved because you're going to be like those executions are going to be running on like different modal workers, so you can't guarantee they'll be preserved. So the details of the setup aren't super interesting. Maybe I'll just like quickly talk a little bit about the ML side here. So this is a little bit on the older side as far as diffusion models go. Just haven't really found anybody making a better QR code control net or like QR code generation workflow yet, like a year and a half later. One that still preserves like the fact that the QR codes scan when you generate them. Like it's like cool that lots of them will generate much nicer looking stuff than I'm showing, but it's kind of annoying that it doesn't actually scan when you need to use it. So I really like this Monster Labs model from Hugging Face that has this like QR code control net, and they're like Stable Diffusion 1.5 version in particular actually is really good. Their like Stable Diffusion XL version was like a little bit kind of yeah, like a little bit like more beautiful, less scannable. So then we build that control net is something that goes on top of an existing diffusion model. So you need to use a Stable Diffusion 1.5 or a fine tune of Stable Diffusion 1.5. A like cool feature of really large models, like things that have high dimensional latent representations, is that you can actually take a lot like components that were trained for interacting with like one model in a model lineage and then actually like reuse it with another model. So I take advantage of that to use this Lycon Dream Shaper model. So this is not Stable Diffusion 1.5, it is a fine tune of Stable Diffusion 1.5 that has like, maybe some slightly better aesthetics. I can't take credit for coming up with that idea, by the way. Some of this, like this part comes from the original QR code, some of the original QR code workflows that were posted on Reddit a year and a half ago when this whole like workflow took off. So that's all I'll say about the ML here. I think there's like a lot of kind of fun and interesting work to do here on doing this stuff better. I think people kind of got distracted, started working on other things. So it's like, yeah, could make these QR codes more scannable and more beautiful. Watch this space. Okay, so the generation part is not like particularly interesting. We're just using Hugging Face diffusers here. And so we're just using a little like pipeline, and then we return raw bytes. So this is another thing, like a nice way to kind of create separation of concerns is to use like the simplest, lowest level data types possible. So in this case, it's like the bytes of an image instead of like a pill image. So then the clients of this thing need to know how to read bytes, but they get to decide how they read bytes. They don't have to have the exact same version of Python image libraries available, yada yada. And so that's like I've found like working on a bunch of examples and applications on Modal has bytes pilled me. It's convinced me to go for these like simpler data types at the interfaces with like data models more internal or like complex types more internal to my like libraries and applications. Okay, so that's how it runs. That's how I like I showed you modal run for how I test it. I showed a couple of deployment plans. There's one more piece of testing that I haven't covered, which is the like, easily repeatable end-to-end testing. So that's in tests. We aren't exactly at like 100% test coverage on this bad boy, but we do have one little like end-to-end test. So this one hits a development server with like a quick end-to-end, like, can I hit it? Then poll by checking these like job states, and then get the results, and then like save them to a file, and it looks like a QR code. So this end-to-end test here is like very much a smoke test, not like a test in detail, not really like a proper integration test, and not certainly not like a unit test of any kind. But it's like this smoke test. Make sure things aren't totally broken. So let's do end equals dev make API. So this will, oops, we want to go up to that same folder. There we go. End equals dev. One thing I actually will say is like I'm showing you this make file workflow here, but honestly, like at Modal internally, we use invoke, and you can see this in, I think you can see some of this in our like the GitHub actions for our examples repo. You can see that we're using it. Invoke is like a sort of Python-y make file. Like it's a way to write things you might otherwise write in a make file in a Python script, and it's way nicer and cleaner. So like, but I hadn't found out about it when I wrote this code a year and a half ago. So we're stuck with the make file. So, there are any number of ways to do this, make being just one of them. Okay, so we ran our make file, created a development server for testing. And then now we should be able to Python test / test end-to-end.py. Oh no, it's pytest. Should be able to just pytest then. Actually, so the proper way to do this would be make tests, so that I don't have to think about like how exactly do I run my tests, what pytest flags do I use. So yeah, so the answer is it was actually pytest, but make test creates a little interface so that I can so I don't have to worry about it. Okay, there we go. So this is like there's a little bit of timing information included there. So once I like put this up in GitHub Actions, I'm at least saving some of the timing information for tracking performance over time. Yeah, it looks like it took about 10.5 seconds to run. Yeah, so that again just catches like, oh, the typing did like an egregious typing error that was not caught by the linter, things like that. But yeah, so that's a tour of this whole code base that's like closer to a production application running on Modal than anything that we have in our examples. So if you're interested in, I think it's a little hard for us to accept open source contributions on this because it's not really like architected, like ML projects in general are pretty hard to take open source contributions. Maybe the web API stuff, some of the testing and CI/CD are places where we could get open source contributions, but the ML part is pretty hard to do, just because it's so hard to test and so hard to verify patches that people submit. But if it's not that, it's at the very least a nice like sort of demonstration of certain patterns that you can use yourself in building an application on Modal, from like where to put API divides, where to use REST versus a more RPC style interaction, like how to integrate with asynchrony, a couple different testing patterns. It's all in there, and you can check it out. And maybe use some of these patterns yourself in your own applications. See you at the next webinar. Look forward to seeing what you build. Take care.